Welcome to CAD Road. Today we will study the example of the top-down design of a simple product in NX using the control structure. As an example, we will take the model of a ball bearing. The mock-up of this product you are currently seeing at your screen. This is a very simple model. It contains two rings, inner and outer one, the separator subassembly, which itself consists of two identical separator rings, and 13 balls. If we unpack the assembly navigator, we can see each component separately. The product structure is correct, the number of components is right. This is a good product model, which seems just about right. But let's have a look at what are the components made of. Let's have a look at their feature trees. And we can see that feature tree of every component contains only datum coordinate system and wave-linked solid body. Nothing else is contained there, and thus we can conclude that the actual modeling of the given geometry was done elsewhere. Also we see that the links are associative, what means that connection to the parent geometry is not broken. Everything we see is evidence of the presence of the control structure. Control structure, which we can observe if we open the parent of the product mockup, is the auxiliary assembly, which contains three principal parts. Our ball bearing is contained as a subassembly in one of the parts, namely a result part. But our work begins in the source part. Modeling of geometry is done in the work part, and the result part, as I mentioned, contains the mock-up of the product which we are designing. Let's have a closer look at each of the parts. As I mentioned, our work begins in the source part. This part contains conceptual parameters. You can see that this particular source part contains only two sketches, which are driven by a limited number of conceptual parametric expressions. There are only 5 of them: inner and outer diameter, width of a bearing, ball diameter and number of balls. Here you can see how sketches are made. They are very simple. At this stage we don't need complex detailization of sketches, we are only interested in the fundamental parameters. Now let's have a look at the work part. The first thing that we should notice is that via interpart expressions and wavelinks, the work part receives conceptual parameters that are contained in the source part. Therefore, all changes made in the source part will automatically be repeated in the work part. Fundamental sketches form the basis for all subsequent sketches, which in turn form the basis for the solid bodies, which represent geometry of the product components. The primary advantage of this methodology is that all parts are modeled in context of each other. Changes to the initial parameters, or in the bodies which serve as a context for other bodies, are immediately repeated throughout the feature tree, and thus all product geometry is changed consistently. Assembly designed by this methodology will not have any problems with misalignment or mismatch of components. Solid bodies modeled in the work part are wave-linked into the components of the product mockup assembly. These are the same links which you saw in the beginning. Now let's change the conceptual parameters in the source part and have a look at our control structure in action. Let's open the expressions window of the source part and fill in the values corresponding to the smallest size of a ball bearing. We can see that the update is occurring. The product mockup gets rebuilt according to the new parameters in a correct way, and geometry of all the components remains mutually adjusted. Product structure remains correct, the number of balls there matches the number which we entered in the source part, and separated geometry again corresponds to that number. Let's now enter the values for the largest size of the bearing and see that the control structure in this case again works as intended and update of geometry is fully coordinated. Once again we get absolutely correct product mockup, it is updated according to the specified size and all geometry there remains mutually adjusted. Thus we can ensure that the top-down design strategy has an obvious advantage of allowing us to build mutually adjusted geometry right from the beginning, by providing a context inside of which the whole modeling process is kept. If you are interested in the effective utilization of NX CAD software, I advise you to visit our blog at caddraw.com, which we publish in both Russian and English languages. Thank you for watching.